Welcome to aminacademy.com. In advanced calculus, let us discuss about limit of sequence sum solving problem. Look at this example. Find limit n tends infinity 1 plus 1 over n whole power n. We have to prove it is e. Now, for this, we have to use binomial theorem. By using one plus x power n is equal to binomial expansion 1 plus nx plus n into n minus 1 by 2 factorial x square plus n into n minus 1 n minus 2 by 3 factorial x cube plus n into n minus 1 n minus n plus 1 over n factorial x power n. By using this binomial theorem, let x equal to 1 over n. That means you are using here excess 1 over n. What happened? That is un. N of 1 plus 1 over n power n equal 1 plus use ns excess 1 by n, that is n into 1 over n plus n into n minus 1 by 2 factorial 1 over n square, that is x square, then plus n into n minus 1 into n minus n plus 1 by n factorial into 1 over n square. Now, which is equal here 1 plus n into 1 over n is another 1 plus 1 over 2 factorial is take out here, that is here n into n is n squared minus n divided by n squared is n squared by divided by n squared is 1 minus 1 over n plus similarly 1 over 3 factorial gives 1 minus 1 over n, 1 minus 2 over n, like it continues, plus 1 over n factorial, 1 minus 1 over n, 1 minus 2 over n into 1 minus n minus 1 by n. These are substituting excess 1 over n. Then now we have this expansion. It's also clear. It is also clear that one plus 1 over n power n is lesser to 1 plus 1 plus 1 by 2 factorial plus 1 by 3 factorial up to 1 over n factorial, which is lesser to 1 plus 1, 2 factorial is 2, 1 by 2, 3 factorial is 1 by 2, 1 by 2 square, 1 by 2 square, 1 by 3, 1 by 2 cube, like it goes. Then plus 1 over 2 power n minus 1, which is lesser than 3. That means this expansion is between 2 and 3. So it approaches, therefore un approaches the special value e by using Euler's rule. That means this e value found by Euler, then which is approximately equal to 2.7171828. This is a rational number. So we got un this is not your coordinate, it's un. Then 1 plus 1 over n for n, the value is, that is limit extends to infinity, 1 plus 1 over n power n is equal to e. That e value, we got it this. Now next question. We have to find some limits of some expression. Look at here. Limit n tends to infinity, n plus 1 minus square root of n plus 1 minus square root of n. So it is expressed as limit n tends infinity. Here rationalizing, that is multiply up and down by that conjugate of this square root of n plus 1 minus square root of n plus 1, which is equal to square root of n plus 1 plus square root of n. That is, look at here, square root of n plus 1 minus square root of n, which is multiplied by square root of n plus 1 plus square root of n over square root of n plus 1 plus square root of n, which is equal to limit n tends to infinity. Here a minus b, a plus b is a square minus b square. A square is n plus 1 minus b square is n over square root of n plus 1 square root of n. Here n and n cut, which is equal limit n tends to infinity 1 over n plus 1 equal, because here 1 over infinity, it tends to 0. So we got 0, because if you substitute n equal to infinity here, so 1 over square root of infinity plus 1 plus infinity square root of infinity, which gives infinity. So 1 over infinity is 0. Next question. Here limit n into n plus 2 over n plus 1 minus n cube over n square plus 1. Here, which is equal limit n tends infinity, then taking LCM as n plus 1 into n square plus 1 by cross multiplying then which is equal n cube plus n square plus 2n. That means you have to multiply with n square plus 1 throughout. This one gives n cube plus n square plus 2n. That is, here after simplification it gives like so, which is equal to limit n tends infinity. We have to divide by n cube throughout. It becomes n cube over n cube is 1 over n, 2 over n square over 1 n by n. Divide denominator by n every time. That is, n by n is 1 over n by n squared here. That is n squared by n square is 1 plus 1 over n square, which gives, if you give n is infinity, this become infinity, this become infinity, the other become infinities. Thus equal 1 plus 0 plus 0, that is 1 over infinity 0, 2 over n square, infinity square is also 0, here also 0, here also 0, which becomes 1 plus 0 and 1 plus 0, which is equal to therefore 1 over 1 equal to 1. One more question. 2n minus 3 over 2n plus 7 whole power 4, which gives limit n tends infinity. Here divide throughout by inside by n, which gives 2 plus 2 minus 3 over n over divide the denominator by n, it becomes 2 plus 7 over n whole power 4, which gives, applying the limit n is infinity, 3 over n is 0, here 7 over n is 0, which becomes 2 over here little bit 3 here. Now this is 3 plus 0, which is equal 2 over 3 power 4 equal 2 over 4 is 16, 3 over 4 is 3 over 4 is 27. Now 81. So we got the result. So far we discussed some limits of the expression with respect to n tends infinity, and also we discussed about the special limit n tends infinity into 1 plus 1 over n power n is equal to e, Euler's number. We have done. Please subscribe our YouTube channel.